Chapter 1. ACE, the AWS Well-Architected Framework. When you are developing and deploying applications in the cloud, it's easy to get too much focused on the end result due to requirements of the speed and agility. However, it is important to keep in mind that creating technology solutions is a lot like constructing a physical building. If the foundation isn't solid, it may cause structural problems and undermine the integrity and function of that building. Starting from the initial design phase to the recurring review of your workload, it is important to ensure that your architecture is in accordance with the best practices. This ensures that your workload environment continues to function and deliver results the way it is supposed to do in the short as well as long run. The AWS Well-Architected Framework is a collection of such best practices which you can benchmark your systems against and ensure that there are no surprises at any stage of your journey in the cloud. The document itself is a very detailed document, and at some point you could feel like drinking from a fire hose. You can decide to use your weekend's time to go through it, but for now, we come up with a short summary of it in order to ignite your interest in following the best practices in the cloud. Introduction. The Well-Architected Framework is a framework to measure applications running in the cloud against a set of strategies and best practices. The framework has been compiled by AWS after working closely with thousands of customers. The purpose of this document is to empower people to make informed decisions about their cloud architectures and help them understand the impact of their decisions. The program is a starting point in the architectural process that should be used as a catalyst in further thinking and conversations. General Design Principles. There are three main components of the Well-Architected Framework: General Design Principles, the 5 pillars, review or questions. Let's go through these components one by one. Cloud computing has opened up the technology space to a whole new lot of thinking, where constraints that we used to have in the traditional environment no longer exist. When thinking about design principles, it's interesting to know how the things work out in contrast to the traditional environment. 1. Stop guessing your capacity needs. In the traditional environment, you had to guess how much infrastructure you needed, and that was often based on high-level business requirements and demand. This exercise is usually done before even a line of code was written. With cloud computing, you no longer have to do the guesswork. You can start with a bare minimum capacity needed and scale up on demand to whatever and whenever you need. 2. Test systems at production scale. In your on-premises environments, you could not afford to test at scale, i.e., it was simply economically not a feasible thing to do. So you went to production and you would see a whole new class of issues that would arise at high scale. In cloud, you can create test scenarios at production scale and calibrate your resources and terminate them after you are done. This ensures that there are no surprises when there is a huge event planned, and the numbers given your marketing guys don't match up with the actual traffic on your application. 3. Automate to make architectural experimentation easier. With cloud-native workloads, you easily replicate to workload through automation. This allows you to run your do experiments on your architectures easily without putting in manual efforts and downtimes expected in traditional workloads. 4. Allow for evolutionary architectures. Any proof of concepts or architectural experimentation in traditional environments was done by hand and was only generally done at the start of a project. You generally had to have a static architecture that was confined, and it was difficult to even think about making a change. With cloud, you can automate your changes and test them. This gives business more scope to innovate at a faster pace. 5. Drive architectures using data. With traditional environments, you probably used models and assumptions to size your architecture versus modeling based on larger datasets. When your application infrastructure is based on code, You can collect data and understand how changes to it affect the workload. This can help you design the architecture using a considerably large data set as compared to your on-premises infrastructure. 6. Improve through game days. Finally, in traditional environment, you would exercise your runbook only when something bad has happened. In the cloud, these constraints have been removed. You can afford to simulate events or break things intentionally and get your team to check your operational readiness and resiliency to any failures. This is also a good platform when all the different teams can come together and understand dependencies between the systems, especially in case of failures. The 5 pillars. The 5 pillars of the well-architected framework, i.e., operational excellence, security, reliability, performance efficiency, and cost optimization, help to provide a stable and consistent base which you can use to initially design your infrastructure and keep referring back to as the infrastructure evolves. If you go through the details of each pillar individually, you would also learn about focus areas in them with respect to design principles for each pillar, definitions, and best practices. Here is a summarized version of the 5 pillars. Security. Use a model of zero trust when thinking about security in the cloud. You should see application components and services as potentially malicious entities. This means that we need to apply security at all the levels in the cloud. The following are the important domains involving security systems with zero trust in the cloud. IAM, Identity and Access Management Services in AWS, allows you to create role-based access policies with granular permissions for each user and service. When working with identity management, you need to ensure that you have strong sign-in mechanisms, store temporary credentials, audit the roles and credentials periodically, and store the passwords securely. You can leverage AWS services such as IAM, Secrets Manager, and AWS Single Sign-On to meet your requirements. Network security. This means adding multiple layers of defense in your environment to harden it against any threat. The most basic components to be used is the VPC, which you can create your own virtual private cloud, which is isolated from other customers' resources. Within the VPC, you should segregate the placement of your resources depending their requirement to be internet-facing or being internal components. On top of that, you should make use of granular controls such as security groups, network ACLs, and route tables to prevent malicious users from gaining access to your resources. On top of it, your environment should be built to withstand external attacks based on common risks, such as OWASP top, then using WAF, as well as mitigate volumetric DDoS attacks using shield services. Data encryption and protection. As AWS customers, you are responsible to protect your data. This should be done starting with the data classification and dividing into categories based on criticality and access level. Based on the classification, you should design your architecture to use services which offer expected availability and durability. For example, S3 service offers 99.9999999% durability of your objects. Similarly, in order to protect your data, you need to have measures in place such as encryption in rest, KMS, and encryption in transit, SSL/VPN. Performance efficiency. This pillar focuses on efficiency and scalability. With cloud, you can handle any amount of traffic, so you don't need to configure your services with scale in mind. In the on-premises model of doing things, servers are expensive and it may take a long time to deploy and configure them. In that model, The servers used are mostly of the same kind, and there may be one server doing multiple functions. The better way to do in cloud is provisioning a cheap and quick solution, which also has the freedom to choose the server type that most closely matches the workload. Because every server is interchangeable and quick to deploy, we can easily scale our capacity by adding more servers. The two concepts for performance efficiency are 1. Selection, ability to choose services which match your workloads. AWS has over 175 services to match your workload. Achieving performance through selection means being able to choose the right tool for your job. 2. Scaling. Choosing how the service scale is important to continue performing. There are two types of scaling. A. Vertical scaling, increase size. B. Horizontal scaling, increase numbers. Consider an example of your web application server using EC2 instances in an auto-scaling group. As your traffic increases, you can have scaling policies in place which automatically add new instances as your load balancer targets when the threshold increases preset limits. Similarly, for SQL-based databases such as Aurora, you can configure vertical scaling to increase your database capacity. It is important to continuously monitor your application workload and measure it against specific metrics to set a trigger point for scaling. Reliability. This pillar focuses on building services with resiliency to both services and infrastructure's disruptions. You should architect your services with reliability in mind. We can think in terms of blast radius. That is the maximum impact in event of a failure. To build reliable systems, you need to minimize the blast radius. One of the most common components is spreading your resources across multiple availability zones. You should have automatic triggers in place in order to mitigate impact to the application in case of certain failures. While autoscaling is a service which helps you create a fault-tolerant server environment at scale, you should also consider using microservices-based architecture wherever possible. With microservices-based decoupled architectures, changes or failures in one API or components do not break the functionality of your application entirely, and they also help you recover quickly from failures. Lastly, you should also have DR strategy in place, which could either be in form of a data backup or a backup environment in other regions, on-premises, or a multi-cloud environment. Operational excellence. This pillar focuses on continuous improvement. You need to think about automations and eliminating human error. The more operations can be automated, the less chances of an error. In addition to less error, it also helps you continuously improve your internal processes. When you want to gain as much insight into your workload as possible, then you have to think about the right telemetry data. Using the most common sort of monitoring available in form of CloudWatch metrics, you can keep an eye on your resource load. Further, you can get additional logging by pushing your application logs to CloudWatch logs. This does not stop here. In addition to getting the telemetry data, you need to set up alerts with the right threshold to make the actual use of the metric and logging information. If you have an event for which you are generating an alert for, then set up your runbook for it to handle it. As an important aspect of the operational excellence pillar, it is important to automate and improve your reaction to the alerts constantly. This ensures that your reaction is error-free, and you do not have to wake up your on-call engineer at 2 a.m. in the night when one of your servers starts throwing HTTP 500 errors. Cost optimization. This pillar helps you achieve business outcomes while minimizing costs. Cost optimization in cloud can be explained in terms of OPEX instead of CAPEX. In simpler terms, OPEX is pay-as-you-go model, whereas CAPEX is one-time upfront payment or huge yearly licensing fees. Instead of paying a huge cost upfront, cloud gives you option to invest in innovation. With AWS, you should make use of tagging of your resources to check the bill amount corresponding to each project and group of resources. This helps you identify improvement areas in terms of workload distribution. You can also make use of findings of services such as Trusted Advisor, which provide your insight into the utilization of resources and if you should downsize to an optimal value to reduce your costs. Further, you can set up billing alerts to ensure there are no surprises at the end of the month because one engineer decided to use a NAT gateway to download terabytes of data from S3. While you can set up your architecture with optimal cost, it is also important to keep yourself up to date with the latest features and service release, as they can help you further reduce your costs by slightly modifying your environments. Some of the examples include using gateway VPC endpoints instead of NAT gateways, or using shared VPC architectures for services which are commonly used across your organization and remove duplicate resources. The review process. This is a stage where you get things in action. The review process is where you get your team and resources in one place and answer a set of questions to see if your architecture meets the best practices highlighted in the 5 pillars. The answers to the question during the process of going through the well-architected framework aren't right or wrong or yes or no. They are on the business realities and choices that are made for a given system at a given time. So, when working on a well-architected engagement, don't just go through the questions, but also use your knowledge and expertise to build off the framework and do what's right for your given situation. Here are some sample questions from each of the pillars. SEC 3. How do you manage permissions for people and machines? Manage permissions to control access to people and machine identities that require access to AWS in your workload. Permissions control who can access what and under what conditions. OPS 6. How do you mitigate deployment risks? Adopt approaches that provide fast feedback on quality and enable rapid recovery from changes that do not have desired outcomes. Using these practices mitigates the impact of issues introduced through the deployment of changes. TERF 5. How do you configure your networking solution? The optimal network solution for a workload varies based on latency, throughput requirements, jitter, and bandwidth. Physical constraints such as user or on-premises resources determine location options. These constraints can be offset with edge locations or resource placement. REL 7. How do you design your workload to adapt to changes in demand? A scalable workload provides elasticity to add or remove resources automatically so that they closely match the current demand at any given point in time. COST 4. How do you decommission resources? Implement change control and resource management from project inception to end of life. This ensures you shut down or terminate unused resources to reduce waste. You can also ask to try to evaluate each component or entity of your workload separately against the best practices highlighted in the well-architected framework. This will give you a granular view of each distinct function of your environment. Well-architected tool. Usually, customers are assisted by AWS Solutions architected and technical account managers. However, not all customers get SAs and TAMs, so they can either make use of third-party vendors to do the review process or make use of the well-architected tool from their AWS console. This tool allows you to go do the following. 1. Define your workload and stage. 2. Answer the questions against each pillar of the workload. 3. Get summary of your workload review. 4. Have multiple reviews in place in form of a dashboard. 5. Links to the best practices and videos as highlighted in the pillars. 6. Archive and audit changes to your workload review as you progress. Depending on your organizational cultural, you can do a recurring review every few months. However, it is important to do the review before the start of the design phase of any project. This helps you create a stable foundation for your environment, and all you need to worry about is the functional working of your application.